Okay, in this video, we are going to explore how to find a exponential function and how to graph it. So in the previous example, we were given the initial quantity and the growth rate. Then we will be able to find the exponential function. But what if we do not know the growth rate, but instead we know some input and output pairs of order, and how can we construct the exponential function? Here's an example. In 2002, a company had 80 retail stores. By 2008, the company had grown to 118 retail stores. If the company is growing exponentially, find the formula for the function. So if we let 2002 to be our starting year as our year 0, so that means at the initial value is 0, and then we will have 80 stores, right? That's our x and y. And then in 2008, which means after 6 years, the company had grown to 118 stores. Remember, what does the exponential function look like? It looks like fx equals to a times 1 plus r to the t. So now we have what? We have our a initial value equals to 80. So we plug in 18 here. And then that's equals to fx. Now we can use the second order pair. The second order pair tells me that what? After 6 years, the company has grown to 180 retail store. So that means 180 equals to 18, 1 plus to the 6th. Okay, so now how do we solve that to find out our growth rate? So our growth rate is, so to do the pandas, if you try to solve some equation, we need to do the reverse order of pandas. That means we need to do division first. So I have, when I simplify, I have 9 to the 4th equals to 1 plus r to the 6th. And then we take the 6th root on both sides, so that the 6th power and the 6th root, they can cancel out, right? So the 6th root of 9 over 4 equals to 1 plus r. And then we subtract 1 on both sides. I have r equals to 6th root of 9 over 4 minus 1 equals to r. So now let's calculate. Let me show you the calculation. How can we calculate the 6th root? So you probably learned that at 19.5, Math 19.5 or Math 19.7, a to the s root, x power, roots. We're talking about roots. Let's do a very quick review. A to the s root equals to what? A to the 1 over x. Remember that? If it's not, please go back to review exponential in Math 19.5 or Math 19.7. So that means in here we want to put what? 9 over 4, 9 quarter to the 1/6 power minus 1 equals to r in our calculator. So here is our Google calculator. And how do we do that? Just with Google. So you want to put 9 divided by 4 first. So that is our 9 over 4, right? The fraction means the division. 2, now we need to put a parentheses. 1/6 power, and then equals to whatever that is, and then subtract 1. That will give us the r. So the rate is equals to approximately 0.145. Okay, so that means in general, the function is going to look like fx times the initial value, which is 80 retail store, 1 plus 0.145 to the time, or x. Okay, so the next part is I want to show you how to graph the exponential function. So I'm going to show you a decimal calculator. You can find it on the decimal calculator, Google. So let's take a look. What does the function look like? Y equals to, let's say, initial value, let's put 18, which is the example that we have, 1 plus our rate, 0.145, and then 2, the x power. So now let's take a look. Look, the function look like growing up, right? It's curved a little bit and going up. So let's manipulate a, the initial value, and r, the rate, a little bit and see what does the function look like. Or we can do the simplest function, such as y equals to, let's say a is equal to 1, 2 to the x power. The blue line is also curving up. And now we do another one. You can just play around at your own computer and see what does this look like. 100, and now let's change whatever inside the parenthesis, which is the base of the exponential function, to some fraction, which is 1/2 to the x power. So now it's going down, right? It's a decreasing function if we look at the purple line. So now let's try some another fractional number. What if y equals to 1 to the 6th? A fraction less than 1 to the x power. Okay, it's going to be the black line. As you can see, it's also going down. So now let's summarize it. If the base is greater than 1, right? These are all greater than 1. The function is going to be what? Going up, an increasing function. If the base is less than 1 but greater than 0, which is a fractional number, is going to be going down. So, and then let's say, what do they have in common, all of these 9? Do you see them? They interact in one point, which is 0 and 1. So that means every 9 is going to pass 0 and 1. I'm going to show you later why is that. And then as you can see, as the function grows bigger and bigger, there's an asymptote, right? The asymptote is x-axis.